Great to see you here again. We are starting with a new video in the part about quality management. When we look at quality management and statistical process control, the item I will discuss in this session is related to quality issues and their effects on the costs. Quality issues are very important. They mean that something is wrong, but what does it mean related to cost? What are the effects that we create when we make things with low quality? The first thing that we have to do is to see what basically happened. We were going from crafts to processes. People were basically making the goods with their heart. They were producing products that they loved, that they wanted to do. And basically what happened is that those craftspeople basically were replaced by people working on these continuous processes. The work was not done by one artist or craftsperson anymore. It was going to a, let's say, anonymous process. And when we look at the craftspeople, they guaranteed basically by the way they were doing the work that everything from start to finish was done by them. And they were very proud about their products. Their names, labels, and signatures became guarantees for the quality of their product. Now, from the start of the Industrial Revolution, these individuals making a complete product, were in fact replaced by mass production. And the craftspeople and artists, they still exist, they still make their own art, their own designs, but it's completely different from the process type of products. The products made by those craftspeople and artists, painters, sculptures, and every other art that we can consider, they are still very unique. They carry the name and the quality of the designer, but they are in fact only there for the connoisseurs. They can admire those, they can buy them. Basically, they can be bought by the lucky few because they are very expensive. When we started working on processes, the people working on creation of the product, they were only working on a part and they never were part of the entire process. It's an effect of the people on the fact that they're just doing one little part and they don't feel responsible for the total result, the final result, the end product. And basically this reduces the motivation. The people lose the motivation to excel because they're just doing one part of the work, and that part is in many cases never seen by the people who will buy the finished product. Now, when we look at push production and quality, typically the production processes that we know is that we make things in parts. We provide individual parts that have to be assembled later into a final product. So we have the parts of the engine, people are making those, and at the end they have to be assembled. Now, one of the parts or each step of the process has to comply with specific technical standards. So these standards are described and a part is accepted when it complies with those technical standards. Now, work became automated, less challenging, even boring, and the probability of errors and non-compliance basically increases. And the quality measures that were implemented were in fact in the push production a little bit pushed backwards because we were producing at high quality, we were producing at high speeds, because the more pieces a machine was producing, the lower cost of the item itself. So people were in fact pushing to produce at every step of the process as the highest quantity as possible. And in fact, they tried to create those parts, they're waiting, and it was not accepted that the process would be stopped, because it would be catastrophe for the operations manager, an operations manager who would stop a process which didn't have any breakdowns would be fired on the instance. So basically what's happening, all those machines keep on working, are producing goods. We create a lot of work in progress, we will call it, all those unfinished products or parts, and in fact we would only see that there are issues later on, even issues that were not detected by the quality, the typical quality processes that we would implement. On the other hand, the machinery would break down because there is a lack of maintenance. We don't know what's going on. And we all know when you go for a maintenance for your car, for example, they verify certain items that have, let's say, an element which is quite important, is that when you go to the maintenance, they verify if certain parts will become defective over or between the period between the two inspections. If you detect something like that, you know you can order the part, you can plan the interruption of the machine, you can repair it. But if something goes wrong and a certain piece breaks down while the machine is running, it could cause much more problems than when you would stop the machine to repair it. And these are all elements that were not considered. People were just producing. They were pushing, and basically the quality was low. A lot of work in progress, late detection of quality, and other problems like that. Instead of saving money, they were in fact throwing money away. The effects on bad quality are in fact the effects of bad quality. Well, when we look at the production setup and when people lose the link with the final product, it means that they're not motivated, and basically the quality becomes an issue. Now, the initial quality controls were basically done at the end of the production line. For example, when a completed car was tested and the inspection team was supposed to discover all the problems in the final product. I remember a story, my father told it, and perhaps you've heard it before. It means that one young guy was working on the production line. The older guy, the coach, was forgetting some part, let's say a wrench in the engine. And the young guy said, "Hey, sir, we forgot the wrench. We should take it out." And the old man said, "It's not our problem. It's the problem for the person at the end of the production who will do the quality control." And this creates, of course, a lot of problems when you find things, when you have to identify these things at the end of the production line. And it's not good for the company to have products with all these faults. It costs a lot of money, and some may be detected even later when the goods have been sold. Now, what could happen? You could completely disassemble the car when you have, let's say, during the startup, you may have parts that are even more damaged, like the engine that I just mentioned, and you have to rework. And I think I read somewhere that the time to do the quality control in a certain factory, I think it was like Volkswagen or Porsche or BMW, I don't remember. It was longer than making a complete car. So basically all the controls had to be done at the end. And that was causing a lot of delays, a lot of quality issues. And the worst problem is that the processes were not improved to deal with that. Now, like I said, the individual workers do not have any sense of ownership, and it's one of the main causes is that motivation of the people. Also, when machinery that is not properly maintained is working out of specifications, and as long as the machinery continues to operate, it's creating bad parts, and we will find out that these parts are not compliant, And the operations managers typically would say, okay, we will make up the additional time, we work faster, we go to a higher production speed of the machinery, or we will work overtime. Anyway, these things have an enormous impact on the cost of the production and of course of the profit of the company. Now, when we look at costs and quality, bad maintenance, processes out of control, accelerated production rates are in fact the main reasons why things go wrong. Now, the mentality of the old school operations manager and the general management of the company was that interrupting a process, even to remediate a problem or conducting maintenance, was unacceptable. Production must go on at whatever cost. Basically, the most important element that people were forgetting was the cost of all the work that was wasted due to bad quality. Machines that broke down, took longer repairs times than expected because the parts had to be ordered. And all these things together basically were hidden costs that the people were not looking at. And they were focusing on higher production rate, working faster. Now, this was discovered by the Japanese when Toyota was working in a different way. They were in fact working in what we will call a full production system. Also because of economical reasons, they didn't have a lot of cash to deal with, so they had to spend the money in a different way. They had to be sure that no money was wasted. And basically, the high quality level of the Toyota cars at that time, which was noticed immediately, was the result of that. Now, when the Toyota cars came on the market, people started to find out that savings could be made. Of course, a lot of companies didn't want to follow this. They have their own ideas. It's very difficult to change. And in fact, today we see that there are still companies not following these principles, but the companies that are successful are in fact following those quality rules that have been applied by Kaizen, by Toyota, and by Six Sigma and other elements, other methods that we know today. Now, it's very important to see that these elements, that the cost of quality, bad quality, is reduced, because it's an enormous cost and people can save money just by working more clever instead of working faster. Now, we can reduce the effects of bad quality. Now, what we have to do, we have to identify what we have to implement in order to reduce the rework, the scrapping, and lost time during the processes and the time to repair damaged tools, for example. But there are other things that we can, in fact, introduce to improve the quality output. Now, the father of scientific management, Frederick W. Taylor, introduced two important concepts. The first one was to relate or to integrate quality in the design. So basically, when we design a product, we can integrate quality elements and finding out how it is possible to reduce errors during production. And the second one was that he identified the connection between high quality, increased productivity, and lower cost. So basically, he found out that quality has a positive effect on the production itself. And we will see that other people, quality gurus like Crosby, relate to this. It's very important to see because Taylor wrote these things at the beginning of the Industrial Revolution. And we see that even though these principles were known, people were not doing it the way it should be. They were looking at reducing cost, false reduction of cost, instead of looking at the quality principles. Bell Labs was one of those companies that introduced control charts to monitor production, and Bell Labs was a very important research laboratory, also part of AT&T later, and later closed, unfortunately. They introduced those control charts to see what's happening with the processes. So we see that people are implementing things to improve the quality and to verify that the processes are working properly. Also, there is a quality control association which was founded with the focus on improving quality and integrating the quality in the processes. Then the production process were still most push processes, and basically the industry introduced Six Sigma concepts and the related tools to increase quality. So basically there were quality methodologies that were introduced to be sure that quality was in fact very important, that it was an issue to be resolved, and that we could save a lot of money increasing the quality. The giant steps, of course, came with Kaizen or the TPS, when a pull system was replaced by a push system. A push system was replaced by a pull production system, and basically here we have a stepwise production or quality control, because every step has to be completed according to certain standards, and when we have quality issues, they are identified very quickly. Now, when we look at Six Sigma, TPS, and Kaizen, those are basically the most important concepts that we know today related to quality. We will discuss them in more detail later because they are very important and they are giant steps in the war against bad quality. Six Sigma, perhaps I mentioned it before, or you already know it, was developed by Motorola in the 1980s. They even trademarked the term, and let's say the Six Sigma concept, the focus is on process improvement by identifying defects and limiting them to less than 3.4 defects per million. So basically we're trying to find out what are these defects and what can we do to reduce them, and step by step we increase the Sigma level. So slowly we come to the Six Sigma. Six Sigma is data-driven and is based on extensive measurements and analysis. The focus is 100% on quality. Kaizen and the TPS are different in nature. Like I said before, Toyota didn't have the, let's say, the almost unlimited availability of cash. So they had to deal with financial limitations, and they wanted to reduce the work in progress. They wanted to finish the product as quickly as possible, because you cannot sell work in progress. You can only sell a product when it's completed. So they tried to focus on that. And in combination with the classical tools, the pull production limits inventory to a minimum, and they have automated detection systems of errors which are integrated in the processes. And the people have the power to stop the process when something is going wrong. So basically, the moment an issue is detected and they have systems to detect those errors, the process is stopped immediately. So this was my introduction to cost and quality. Cost and quality, very important. It's very important to understand for an operations manager or any manager in any company that quality can create, or bad quality can create, very high costs. Good quality has a cost, but the costs will be compensated by the fact that your finalized products and services have a higher quality, have less rework, and so on. So basically, quality, investing in quality is a good investment. Let's continue, and I will see you in the next presentation. Thank you, and bye-bye.